friends, welcome to Quick Learn tutorial series. In this video, I will explain you asynchronous and synchronous data transmission. Now before I discuss synchronous or asynchronous data transmission technique, first we know about serial data transmission because asynchronous and synchronous data transmission are the type of serial data transmission. So first we know about what is data transmission. When we are talking about communication between two components, we say that one component is sending the data and another component is receiving the data. These exchange of data between two devices is called data transmission or data communication. There are two ways of communicating the data or transmitting the data: serial data transmission technique and parallel data transmission technique. So, what is serial data transmission? In case of serial data transmission, the data bits are transmitted serially over a common communication link, one after the other. So, here I explain with the help of example. This is the sending device, this is receiving device. If sender want to send data, it send data using a common communication link or using a single communication channel, that is also called data bus, and all the bit transmit one by one in a serial manner from sender to receiver, and receiver receive the entire data but one by one using a common communication link. So this is the way of transmitting data is called serial communication. In case of serial communication, the information transmit over a long distance because only a single channel is required to transmit information. But in case of parallel data transmission, if we want to send data parallelly between sender and receiver, if we send n number of bits, n number of channel is required to send the data. But that process, it means the parallel data transmission process is fast as compared to serial data transmission. Serial data transmission, the bit transmit over a single channel one by one. But in case of parallel data transmission, number of bit can send simultaneously at the same time. So parallel data transmission is faster as compared to serial data transmission. But the advantage of serial data transmission is the serial data transmission is used for long distance communication and parallel data transmission is used in short distance communication. So this is serial data communication technique. Now the classification of serial data transmission. There are two types of serial data transmission: synchronous serial data transmission and asynchronous serial data transmission. In this video, I will explain you synchronous and asynchronous data transmission technique in detail. So first is synchronous data transmission technique. Here the name indicates that synchronous transmission needs synchronization between the transmitter and the receiver in order to allow the communication between two devices. So in case of synchronous data transmission, a common clock pulse is shared between transmitter and receiver in order to perform the synchronous communication. This means data will be transmitted between sender and the receiver only after a constant time interval. Now, in synchronous data transmission, data flow in full duplex mode. What is full duplex mode of transmission? In case of full duplex mode, the sender and the receiver, both devices can transmit and receive data at the same time in the form of blocks and frames. In synchronous transmission, for synchronization, external clock pulse is used. So here we see in the diagram, this is sending device, it means it is a sender. This is receiving device, it means it is a receiver. So sender and receiver share a common external clock pulse for synchronization, and data is transmitted in the form of large block or frame. It means the data is transmitted continuously. There is no gap between the data. In this case, a huge amount of data can be transmitted between transmitter and receiver once the clock pulse is sent. The time interval is decided by the frequency of external clock pulse. So basically in synchronous transmission, a clock pulse decides when to transmit the data, and for this both transmitter and receiver must be ready to have communication. Now asynchronous data transmission technique. Asynchronous data transmission is a type of serial data transmission that follow a non-synchronized form of communication. It means there is no external clock used for synchronization between sender and receiver. In place of clock pulse for synchronization, they use a parity bit, also known as start or stop bit, at the start and end of the data byte. So here we see in the diagram, this is sending device, this is receiving device. These sender and receiver perform asynchronous data transmission. So there is no clock pulse for synchronization. For synchronization, they use parity bit, start bit and stop bit at the starting and ending of the data byte, and a gap introduced between each byte of data. So if we want to send a data byte, this data byte is 10 bit long because 0 is the start bit, add at the starting of the data byte, and 1 is the stop bit, add at the end of the data byte. So when the receiver receives 0, the receiver know the data byte is start, and when receiver receive 1 at the ending, he know the data byte get end. So in this way, data is transmitted in asynchronous data transmission. Asynchronous data transmission, data flow in half duplex mode. In case of half duplex, sender and receiver both can transmit and receive data but not at the same time. When sender send the data, receiver only receive. When this device can want to send data, this device receive, but not at the same time. Or in asynchronous data transmission technique, one byte or a character at a time will be sent. Asynchronous transmission does not require a clock pulse for synchronization. Rather, it uses the parity bit to tell the receiver how to interrupt the data. This parity bit is known as start bit or stop bit, which control the transfer of data. So here we see in the diagram asynchronous data transmission between the sender and the receiver. There is no clock pulse for synchronization. They use, in place of clock pulse, parity bit. That parity bit tells the receiver how to interrupt the data. A gap introduced between the two bytes. When 0 is coming at the receiver, receiver must know the data byte is coming or the data transmission is start, and when 1 is coming at the end of the data byte, the receiver know the data byte is end. After that, a gap is introduced. So in this way, asynchronous data transmission will be held. So asynchronous data transmission is a slow process as compared to synchronous data transmission, because in case of asynchronous, here we use a parity bit, start or stop bit, or a gap between the two byte of data. Now, difference between synchronous and asynchronous data transmission. This is synchronous transmission and this is asynchronous transmission. In case of synchronous transmission, data is sent in the form of block or frame. In asynchronous transmission, data is sent in the form of byte or character. Synchronous transmission required a clock signal between the sender and the receiver to inform the receiver about the new byte is coming, or for synchronization. Asynchronous transmitter does not require any clock signal between sender and receiver. They use parity bit, which indicate the start of new byte. In case of synchronous data transmission, external clock is used. In case of asynchronous data transmission, internal clock is used. Synchronous transmission is fast, asynchronous transmission is slow. Because asynchronous transmission, data is transmitted in the form of byte or character, and we add a parity bit, start bit or stop bit for synchronization, and gap between the byte. That make the whole process slow. In case of synchronous data transmission, transmitter and receiver having common clock. In asynchronous data transmission technique, they having separate clock. Synchronous data transmission is costly because they require a clock signal for synchronization between sender and the receiver. Asynchronous transmission is economical because there is no clock is required for synchronization. Only we use a parity bit, start or stop bit for synchronization. Asynchronous transmission, time interval of transmission is constant. Asynchronous transmission, time interval of transmission is not constant, it's random. In case of synchronous transmission, there is no gap between the data. Data transmit in the form of large block or frame. So it is fast communication system. In asynchronous transmission, there is gap between the data. It means in asynchronous transmission, there is gap between every byte of data. This gap is used for synchronization between the sender and the receiver. Along with this gap, a parity bit is used for synchronization between the sender and the receiver. Synchronous transmission is the efficient way of data transmission along the line. Asynchronous transmission is less efficient than synchronous transmission because the transmission line remain empty during gap in character during transmission. Synchronous transmission need precise synchronization clock for the information of new byte. Asynchronous transmission have no need of synchronization clock as a parity bit is used in the transmission for information of new byte. The transmission speed of synchronous transmission is high because in case of synchronous transmission, information transmit in the form of large block or frame continuously. There is no gap between the every byte or data, or there is no start or stop bit for synchronization. In case of asynchronous transmission, the speed of transmission is low because asynchronous transmission for synchronization there is no clock pulse between sender and receiver, so they synchronize sender and receiver with the help of start or stop bit or the gap between the data byte. So that process is slow as compared to synchronous data transmission process.